Circle O.
A, B, C, D, index, N, R, D, T, A, T, secants, A, R, A, S.
Secants.
Secants, actually. Arch of BM is equivalent to arch of AB. Measure of angle BAC equals 40. Points that appear to be collinear are find the measures
of the following. All right. The main thing that I want to talk about is this. BM, the arc BM and MD are congruent. And then angle BAC is 40. So let's find BM. So I see BM over here. And I see DM over here. Let's go ahead and put tick mark to say they are congruent. And now let's find angle BAC. So here's B, here's A, and there's our C. So that's going to be 40. Would you agree angle BAC is an inscribed angle? Then what must be this arc? It should be 80. And we know the arc and the central angle are congruent. So if that is 80, would you agree angle 1 has to be 80 as well? Okay, let's put 80 on here. So we know vertical angles are always what to each other? They are congruent. And then I have a linear pair. So what can I say about this angle? 100 and 100. And I know you're thinking, well, that's not part of the question. Why are we answering it? Look at this triangle. What does our triangle sum theorem say on this? All of them should add up to 180. So therefore 17 must be 40. It's more like a domino effect. Is everyone okay with that? So then the other one that I want to look at is the following. First of all, angle 23 is this angle. All right? But I want to emphasize angle 22. So 22 is composed of this secant and this tangent. If you don't want to highlight it, that's fine because it might look too much of a highlighting, but I'm going to do that for my teaching purpose. And if I were to go ahead and go over the intercepted arc, my intercepted arc is right here. And the other intercepted arc is between here to here, which is our full 180. So we can go ahead and translate something. If that angle is 100, that's my central angle. This is also 100. Or you could say, hey, it's going through the center with the diameter. It must be 180. That works too. So let's see. Do I have any information about this guy over here? They're equal. Since my central angle is 100, if I divide that by 2, each of those arcs must be 50. So then what I can do for this one is, since my vertex is on the outside, I could take 180 minus 50 and divide it by what? 2. So do use your foldable with all the rules with in, out, and on. Good? So let's move on to the specific questions that you guys asked on. Number 3. Everyone go to number 3. How many points of tangencies do I have on number 3? I have one here, and I have one here. It must be a right angle. Let's fill in what I know. AC is 8. So here's my 8. CP is 17. 17 right here. I think I'm going to kind of like emphasize it and say that's my 17. AP is 15. And then BD is 5. And it's asking us to find PBX. Would y'all agree the two similar polygons here has been twisted? Okay? So if I were to say x over 5, I go from x to 5. I know I need 5 has to be right next to the 8. What would I put next to the x instead? 15. So you might realize there's that extra information that we don't need.
Wait, how do you know which one's the right angle?
Point of tangency is always a right angle.
Oh, they're both right angles?
Mm-hmm.
Oh.
Anywhere it meets at one point will always be a right angle to the center. Let's do our cross multiplying. We have 8x is equal to, how many is 15 times 5? 75. And is that a pretty number to even work with? So I think I'm going to keep it as 75 over 8. And let's say you like mixed fractions. You can also say there's 8 can go into 75 at most 9 times, right? And has how many remaining? 3 out of 8. But why not go on further if you can stop at 75 over 8, in my opinion. But they're both equivalent. All right, for number 5. Lily, go ahead and read number 5 for me, please.
In a circle, a chord of length 48 is drawn perpendicular to the radius. The distance of the chord from the center of the circle is 7. Find the diameter.
All right, so we need to draw a circle first. Maybe not so perfect. Oh no, my sticky note's behind this. Oops. All right. If y'all remember what we talked about on the lesson previously, if there's something about a chord in the radius, what do we make horizontal first? The chord is going to be horizontal. And then the radius is going to create. First, we're going to drop a vertical line from the center, and then our hypotenuse. So make sure you do go over your notes. So here's my center. You make a chord. And we make our vertex, or vertical line straight down, which makes it a right angle. Then here's my radius. And I want to emphasize this right triangle. So let's fill in what I know. If the whole chord is 48, and I'm only looking at this part right here, how many units would that be? 24. Let's redraw this out on the side. Here's my 24. Underline the following. Distance of the chord from the center is 7. Your distance will always be the perpendicular part. That right there will be your distance of 7. So let's translate that over. And then it says to find the diameter. So we could find this distance right here and then do what to it? Double, because my diameter goes all the way across 2 of the radii. So 7, 24, and what was it, Pythagorean triple? 25. So if x equals 25, the whole diameter must be? 50. Good, diameter is 50. And they didn't really give us a unit, so I could say just say u as in units. Or you can make up a unit that you like. Okay, what was our next number? 11?
Yes.
Okay. Okay, on number 11, we have our ice cream cone. But this time we're looking at actually the angles. Ooh, let's highlight the intercepted arc. So I told you guys on the last notes, if we're using a full circle, how many degrees do we have to use? 360. So if I know this minor arc is 2x, this major arc is going to be 360 minus 2x. So since my angle is on the outside, we're going to do the larger arc minus my smaller arc divided by what? 2. So I'm going to say 360 minus 2x. That was just a larger one. Minus my smaller arc is again minus 2x. Divided by 2 is equal to the angle, x plus 120. So let's go ahead and simplify this. I want to do 2 things at the same time. Can we multiply by, actually, do you guys want to multiply by 2 on both sides? Is that what you want?
Yeah.
Okay. Could we also combine these 2 while we're at it, maybe? Yeah. So we have 360 minus 4x. And then when I multiply 2 by these 2 components, that's going to give us 2x plus 240. And then let's add 4x on both sides, so we get 6x here. If I do minus 240 on both sides, what do I get on the other side? 120. So what is my x then? Oh. Do we get it? 20? Yeah? Yeah, 20. Oh, I had a brain fart. Okay, questions on that one? Good? So it's all about the 360. So be really careful if the other part is not given to you, because then maybe you are using 360. All right. Ethan, let's read the last one, number 13.
An equilateral triangle with sides of length 12 centimeters is inscribed in a circle. Find the distance from the center of the circle to each side of the triangle.
All right. So center of the circle to the side, that is what we're looking for. Let's go ahead and draw this triangle and also make it big on the side because it is too cramped. So we're looking for this distance. So since we have an equilateral triangle, aren't all the angles 60, 60, 60? So, but then I'm cutting this by half. So how many would this angle right here be? 30. So now I know we have a special right, 30, 60, 90. What information do I know that I can fill in? The whole thing is 12, so therefore half of that must be 6. So let's do our proportion. I have our distance over 6. Y'all remember the ratio of 30, 60, 90?
No. Yes.
No?
Yes. Yes.
Do we need a reminder on the side over here? It was 1, root 3, and 2. So D is opposite of 30, so what number am I going to write on the side? 1. 6 is on the opposite of 60, so we need root 3. And then let's cross multiply. We have D times root 3 is equal to 6. And then divided by root 3, that we kind of don't like. Do we like having a radical on the bottom? That is considered improper. So what was that phrase? Good. Radicalize, I heard? Rationalize is a correct word. But radicalize sounds about right. We like to make up word. And then we know on the bottom 3 pops out, right? So we're done. Our whole numbers can be simplified. We get 2 root 3 and our units is centimeters.